In this video, we're going to construct equivalent equations with construction webs. So complete the construction web by starting with the equation x equals 16 and performing the indicated operations on the equation moving outward. Then complete the table using the equations you created. So we'll complete the table on the next slide, but it's below your web in your packet. Okay. So let's see what this construction web means and how we're going to work with it. So notice in the center we have the equation x equals 16, and these arrows show different operations. So we're going to take the equation x equals 16 and we're going to perform the operation of subtraction, addition, multiplication, division, and it says to do our first operations, which will be this first arrow, with the number 4. Okay. And then in our second set of operations, we have all the different operations listed, and it says to do the second operations with the number 5. Okay. So let's get started. I'm going to start here and work clockwise. So we have x equals 16, and we want to subtract 4 from both sides of the equation. So we have x minus 4 equals 16 minus 4. Okay. Now let's simplify this result where we can. And here we'd have x minus 4 equals, well, 16 minus 4 is 12. Okay, and we're basically going to build up this idea that we can perform these operations on both sides of the equation and make equivalent equations. Okay, but looking at the balance scale, think about what we just did. We started with x and 16. Okay, and if this is a true equation, which we're assuming, this scale is balanced. Well, we took 4 away from both sides. So I took away 4, so let's just draw an arrow. Okay, so this side would be x minus 4, and on this side I also took away 4. So this side would simplify to 12. So if I take away 4 from both sides of the balance scale, it should remain balanced. Okay, and this is the idea we're going to use with all of these. Let's look at the next one. We have x equals 16. We want to add 4 to both sides. So x plus 4 equals 16 plus 4. And simplified, that's x plus 4 equals 20. Okay, and again, you can imagine we started with x and 16. And if we put weights of size 4 on both sides, we now have different expressions on each side, but the equation would still be balanced and true. So this will be an equivalent equation. Let's look at the next one. Okay. I want to use multiplication with 4. So on the left-hand side, I have x times 4 equals 16 times 4. Okay. And notice I'm using the practice of performing the operation on the right-hand side of the expression we're given. Okay. But because of the commutative property, we know that x times 4, we can write that, and we prefer to write that as 4x equals 16 times 4 is 64. And now with division, we're going to take the left-hand side, we're going to write this in fraction form. So x over 4 equals 16 over 4. So the left-hand side is x over 4, and 16 divided by 4 can be simplified to 4. Okay. So now we have 4 equations. We worked with the number 4 in all of them, but we used different operations, and notice that the structure is different. Now let's go to our next set of operations. So we're going to perform division, but not on the original equation. We're going to use the equivalent equation, and we're going to perform the operations with 5. So I need to divide x minus 4, the whole side of the equation, by 5, and the right-hand side of the equation by 5. Okay. So remember, you need to do this to the entire left-hand side of the expression. We're finding the quotient of dividing x minus 4, this difference, by 5, okay, because that's what 12 equals. So the division bar goes all the way across. Let's put this in the box. X minus 4 over 5 equals 12 over 5. Moving over here, we want to multiply both sides of the equation by 5. Okay, so I'm going to write something. I'm going to write 5 x plus 4 equals 20 times 5. Okay. Now notice I put the 5 out front here. Multiplication is commutative, so that's okay. I put it on the right here just to save us a step. But notice we can't just put a multiplication sign here. If we did that, that would mean 5 times x and add 4. But we want the product of 5 and the sum of x and 4. So to write this symbolically, we need to put the x plus 4 in parentheses. Okay, so now this shows our meaning. So just like the entire x minus 4 was in the numerator, we didn't put the minus 4 on the outside. Here, the entire x plus 4 is in parentheses being multiplied by 5. Now, we could distribute here, but we're not going to. We're going to leave it in this form for now because we don't need to simplify. I always like to simplify the numbers, but I'm fine with that expression. It's not too complex. So we have the product of 5 and the sum of x and 4 equals 100. Now for the next one, we want to subtract 5. So I'm going to subtract 5 from both sides. 4x minus 5 equals 64 minus 5. Well, this is as simple as we can make it. And 64 minus 5 is 59. And the last one, we want to add 5 to this equation. So x over 4 plus 5 equals 4 plus 5. So x over 4 plus 5 is equal to 9. Okay. So just take a moment and look at these structures. Notice how here we had division, and in this one we had division. Here it was subtraction, then division. Here it's division, then addition. Okay. And notice how this structure is different. Okay. Here just the x was divided by 4 because we did that first, and you added the 5 to that quotient. Whereas here we subtracted 4 from x first, and then we divided that sum by 5. Okay. So these are very different expressions, similar operations, but the order in which we do them matters. So now let's look at the next slide. And we are going to check that these are, in fact, equivalent equations. Okay. Now, I already wrote these down. If you want to write these down first, hit pause and you can write them down too, or you can write them down as we go. So what we're going to do is evaluate the left-hand side for x equals 16. So the reason we have x equals 16 is because, remember, that was our original equation. Okay. So if I replace x with 16, and this is a true equation, then that means that this is in fact an equivalent equation to the one we started with. So I am going to first write, so we're working with the left-hand side, evaluating it for 16. So x minus 4 equals 16 minus 4, which equals 12. So no, I just made equivalent expressions evaluating for x equals 16. Okay. And now notice in our original equation, x minus 4 should equal 12. Since it does, this equation is true. Now here the left-hand side is x over 4. I'm going to replace x with 16 and evaluate. 16 over 4. 16 divided by 4 is 4, and that's equivalent to the right-hand side of the equation. So the equation is true. Here we have x plus 4. Now I'm going to evaluate when x is 16. And 16 plus 4 equals 20. And the right-hand side is 20, so this is true. Here I'm going to start with 4x, replace x with 16. 4 times 16 is 64. So that does equal the right-hand side of the equation. So the left-hand side equals the right-hand side. So the equation is true. Here I'll start with x minus 4 all over 5. I'm going to replace x with 16. So this is division, but we perform any operations in the numerator or denominator first before we divide. So 16 minus 4 equals 12 over 5. Okay. And I'm going to leave it in this form. We could write it as a decimal, but this is a number. This is a perfectly good answer. And notice it's also our answer on the right side of this equation. So this is true. Here we have x over 4 plus 5. Replacing x with 16 is 16 over 4 plus 5. Now we have division and addition. We do division first. 4 plus 5, which is 9. And the right-hand side of this equation is 9, so it is true. Here the left-hand side is 5 times x plus 4. I'll replace x with 16. Okay. We could use the distributive property, but hey, this is numbers, so why bother? We can add 16 and 4, that's 20. So we have 5 times 20, which is 100. And that corresponds. And finally, 4x minus 5 equals 4 times 16 minus 5. Well, 4 times 16 is 64. 64 minus 5, I write the whole expression, which is 59. And that is also our result here. So the equation is true. We check to make sure that all of our equivalent equations we created were equivalent to the equation x equals 16. And this isn't necessary to do every time, but I hope you see that it's a good process to undertake because you can really see the structure of what these equations are building. Notice how differently we did these equations. Here, based on the order of operations, we needed to subtract first and then divide. Okay. And here we needed to divide first and then add.